Hi, my name is Norm. I'm a chief technical support engineer. And recently I encountered a case where somebody was asking about the ability to do certain types of plots and comparing certain things that you can do in other languages versus LabVIEW. And in this conversation, the question of a vector field plot came up. And hey, how can I do this in LabVIEW? It's easy to find maybe a download in Python to do this. And I'm not necessarily the expert in vector field plots, but I do get the concept. I've seen enough math training, and I'm a big fan of a variety of YouTubers that, three blue, one brown, that talk about a lot of stuff, and they use these same types of graphs or these plots along the way. And so I figured, hey, why not try to actually connect some dots, be a connector, and see what it takes in LabVIEW to do this. Now, by default, one of the things that I had done is really I just wanted to make sure that I knew what I was talking about with necessarily with vector arrows and vector field plots. So of course I go to Google and I'm starting to look up images of say vector field plots and get reoriented with what make sure I'm talking about the right thing. And one of the very first image hits that I get is this actually an advanced plotting toolkit that you can kind of see here that is available from the community. So of course I went to that and I started to look around and went to that link, and I see that there's already some LabVIEW code that's available for it for doing some pretty advanced things, actually even beyond what I was going to attempt to show how it's possible, even just from stock LabVIEW, how to build up something and do it yourself. And so really, even what's in my mind right now, there's some limitations, and this already is beating it out of the box in terms of community. But rather than go into this specific toolkit, kind of wanted to take a stab at it and just record. So for learning purposes, what would it take for me, kind of from scratch, and just doing like kind of a live coding session of what does it take to do a live, say, vector plotting, and how would I overcome some of the problems. And so hopefully there'll be a little bit of learning from me in this process, and then also for you watching how I work through doing a vector field plot from scratch in LabVIEW, and maybe some of the approaches that I take. So go ahead and sit back. Hopefully it won't take too long. I expect, we'll see how far I can get, maybe in about 20 minutes worth of just some raw coding and LabVIEW diagrams. So let's see what we get. So starting off, I know that in general, I'm going to have to abandon the idea of, by default, trying to do arrowheads on a plot in LabVIEW. There's no real draw arrowheads. Now, I have my own function that I made a long time ago that basically draws an arrowhead on an individual line, actually on an XY plot in LabVIEw, and we're about to get to talking about what that is here, and why we would do something like that. I'll get my whiteboard application started. But in general, we're at least as a minimum going to start with a line starting at a specific point and going in a specific direction, and how would we do that? Now, I'm not necessarily familiar with the exact data set that's necessary for each one of these points. Is it expected that each point is going to going to be every starting point is going to be equally separated? I don't think that's the case. Basically, if I'm not mistaken, I'm going to go ahead and go with the premise here. Once my whiteboard application finally kind of comes up and run, go ahead and try. The presumption of what I'm going to do is basically I'm going to presume that the data set available is that there's basically going to be an array, and probably we're going to need maybe even basically we know that it's going to need to be basically a two-dimensional array, because basically we do have a field that we have to have a bunch of individual starting points at, and then each one of these points is going to have a vector go along with it. And so maybe what we end up doing is we'll have two-dimensional arrays, one of which is the position, and then maybe the next one ends up being the actual the direction, the actual vector itself. Basically the magnitude and the angle. Now, one thing that I know being an RF engineer is, of course, I don't necessarily need a two-dimensional array. I actually can make it'll still be a two-dimensional array, but it won't be X and Y in terms of, hey, what are my positions and what are my vectors? I'll actually have, let's just do a two-dimensional array. Really, it's going to be two columns here. And I'm going to set up my data set to be actually a bunch of complex data. Complex, complex. And the first row here is going to be my position. And then this is going to be the actual vector at that position. And the nice thing about complex data is it actually maps very well to the XY plot in LabVIEW. Now it's going to take a little bit of extra effort to go ahead and do the math for how the XY plot displays the information, but I'm just going to use two complex data sets because really for a complex number basically is two numbers. It's either an I and a Q or real and imaginary or however you as math individuals or whoever you are likes to necessarily do this type of behavior. So I'm going to set up my data set to be a two-dimensional array of complex numbers, and really the first column actually, let's see how to let's do every row. Yeah, every row is going to be a new point, and the first column is going to be position, and then the next one's going to be vector off of that. And I think that should probably work really, really well. So within LabVIEW, I'm just going to go ahead and you can forgive me as I have to my primary monitor. So I'm going to go ahead and just make some constants on the diagram here. Let's do get my quick drop up here so you can see what I'm doing. I'm going to do let's do array constant. So I'm just going to kind of set up my data set, and then I'm going to do a numeric. So this is just going to be a double, but I'm going to go ahead and change the representation to be a complex double along the way. And so now I have a complex double. I'm going to move it into the array. I'm going to change the size of the array. And so now I have effectively a uninitialized, really two-dimensional array of complex information. Now I'm going to go ahead and get my front panel up here so we can kind of look at that at the same time a little bit. And one of the things that I'm going to do is I'm going to go ahead and drop down. I'm going to go ahead, let's use an NXG style, let's see, graph, and I'm going to do an XY graph. Hopefully y'all can see that on there. So indeed, XY graph, you can choose whatever style that you like along the way. So I've got that on the front panel. Zoom back out here. And really, let's just go ahead and fix the axes, because by default, auto scale is always on, and I can guarantee you it's going to make our lives a lot harder when we're trying to see single points or multiple points and things of that nature. So let's just move this up to 15 and negative 15 and 15 and 15. And I'm even going to make our lives a little bit easier even yet. I'm going to go ahead and kind of move things around here and show the, let's do the graph palette. And that actually showed up on the other side of that one. All right, so we can zoom around and pan around the graph. I'm just kind of turning on some of the features of the graph that are there by default. I'm going to go ahead and do the scale legend too, just in case we need to size things and move them around. And then the other thing I'm going to do is I'm actually fit control to pane, which is a nice little feature because then you can just resize the window and it moves things as you need along the way. So we're just going to go ahead and kind of get it square-ish for the moment. All right, so now we've got our graph. And it's going to be centered at 0, 0 along the way. Now, if I'm trying to mimic that graph that we saw before, you saw that there were no like dashed lines for the individual axes, like 5, 10, 15, 20. Actually, well, we're going to leave it centered at 0 for now. Excuse me. My apologies. Joys of live stream, right? So I'm going to go ahead and actually just change some of the plot properties. It's not too bad. Over the properties of the plot. Excuse me. And then for the axes, I'm actually going to turn the major grid to transparent and then change the major grid for Y to be transparent as well. And so that's just going to be a nice blank canvas. Now, in actuality, I don't like that as much. And so what I'm going to do instead is actually just put that at 0 and double click that one and put that at 0. And so now at least I just have at least my nice center point to visualize where things are at on the graph. And let's go ahead and I think just put that in there. Yeah, that's not going to work in that. So the data type of a two-dimensional array of complex numbers does not go into an XY graph. But before I go much further, I'd like to show you that a single-dimensional array does. Now, unfortunately, it might change that on me. So I'm not, but it did that because it changed the data structure, because you saw that it went from that brown cluster to basically auto-adapted, and when it did, it kind of redrew the plot itself. So that's part of the quirk with that one. But that's not so bad. So I'll go backwards. And we're going to leave this plot, so I might have to set that up again in the future, but that's not so bad. Actually, what I can do is if I set my marker spacing to arbitrary, and marker spacing to arbitrary. Now it doesn't matter what I do. It will only have the markers that I have explicitly defined. So that's actually, once again, a little known feature that actually can make life a lot easier using that arbitrary marker spacing. So now if I do this, it stays the same. So no problems there. So what happens if I just do the complex numbers into the graph itself? Well, let's just do 0, basically 0 in there, and then I'll do, let's do 5, 5, right? 5 and 5. So what do we end up with? Well, it did the auto scale on me, so let's go ahead and get that auto scale. We can actually see the auto scale is turned on here by this little lock symbol that you're seeing up here. So I'm going to turn off auto scale, and this is like auto scale once, those two ones that have little indicators right there. So we're going to go ahead and get back off of this and once again set this up to 15, negative 15, and then 15, and 15. All right, so now indeed we have an individual arrow. And so what it did is it's connecting the dots. And an easier way for us to see the dots is basically we need to, turn on the dots because by default they're off for most graphs. And so you can see we have our 2 points and it's basically drawing the lines. So you could say we have our very first vector drawn on here. Once again, without the arrowhead for the moment, we'll get to that. And of course, if I change this to say 1, comma 1, well, it's going to change the vector. Or if I changed it to, 5, comma 1. And so it's very clear. It's really easy to actually draw an individual line on a graph in LabVIEW with arbitrary starting points and ending points. Now, of course, in the structure that we were talking about a moment ago is really we want our initial position plus the vector from that position. So a little bit of extra math is going to be needed along the way, but it's really, elementary algebra for complex numbers, so it shouldn't be too bad. However, you're going to see me trying to do it on the fly without having pre-worked it out in my head to make it look smooth. So hopefully it doesn't get too bumpy. But in general, we know that we can show an individual vector here. Now, something that I can do is actually if I build array doesn't, if I insert build array, that doesn't work. So two-dimensional array doesn't work there. However, if I build a cluster, let's see, that'd be bundle. There's a good likelihood that I can do this with 2 plots, because what I'm trying to do is get 2 plots to show up on the graph itself. And indeed, it did do that. So now let's go ahead and put let's just put this back to 0 here, and put this to negative 3, 5. Okay, so now I have, let's see, I am missing the second plot. It is not showing. So I'm going to go ahead and pause the recording here real quick just to try to figure out. Well, we're just going to, I know that both of these should be shown here, and I'm seeing, if I'm not mistaken, just this individual plot. So I've got to figure out where the other one is in the system. So let's just put this to 1. Let's change that to 1. This is not the best way to go ahead and implement these in the system. Okay, so it looks like it's interpreting the graphs not as 2 separate plots in this case. Let's go ahead and change the baseline. Actually, I'm going to make this bigger. Let's see. So it's not interpreting the data set as I was expecting by default. I know that there's a way to have multiple plots shown on an XY graph, but for the moment, that's why. It's the notorious coercion dot. So in this point, what ends up happening is you can actually see it's done a nice thing for us. It's actually gone through and coerced the data set in actually a way that we didn't want it to coerce. So this is basically the way that I'm setting it up here for the XY graph. It is not appropriate for multiple plots along the way. It's actually turning the data set into, and if I hover over this, if I'm not mistaken, it should show the input and output, but basically it's coercing my inputs to just be real data. So it should be a value of, this is probably the X values and this is the Y values. So my first value here is actually just taking the real component. So it should be at 5, 0, and then at 5, 1. And as we look at our plot over here, indeed, we have at 5, 0 and at 5, 1. So it's not doing the right things, but also I'm not getting the data set in the right manner. So what you end up needing to do actually is the way that this data structure, this very flexible indicator, takes a lot of different type of data structures into it. You can see that we had a few different types being illustrated here. And basically, you can do an X array and a Y array, or you can do a bunch of XY points, XY points, XY points. So what I'm going to do actually is let's try a few different things. So I cheated a little bit. I paused for a moment to kind of flail around, but now we figured out how to take multiple individual graphs and display them as an XY graph. So it was necessary to take each one of those arrays and indeed turn them into their own different data structure. It's a cluster of just the array. So really we just wrapped that element in a bundle node. So that was basically this, not unbundle, sorry, but just this bundle node, which turns basically a data structure into a group of data structure with other elements. And by doing that, it allowed us to contain and now, of course, have two different individual vectors displayed at the same time, just using the complex values. And so if we wanted to say, take each one of these individual vectors, and we wanted to say, start each one of them at a different point, there's a few different ways we could actually do this. Let me see if there's actually, to a certain degree, we can even change this data structure around and make it a much more scalable situation. Let's go ahead and change this into that. Let's see what we got here. Let's say if I wanted this vector, well, once again, vectors are magnitude and angle from a starting point. So we'll do a couple. But we know that this is the data structure we're going to want to use complex numbers to have different lines for the moment drawn on our XY plot. And so now the next step is going to be is like, well, we can draw the lines, and what should the next one be? Let's go ahead and let's have everybody start at 0, 0 for a moment, just to kind of make, because basically every vector is going to need basically a different starting point. So we'll just have everybody start at 0, 0 and kind of move things around and make it a little bit different along the way. And then we'll need to do color coding of the graphs to do every individual plot along the way if we really want every line to be different or have a different color associated with it. So now we've got a bunch of different plots. We have basically the whole reason why we have the array is basically so that every value can just start off at, basically you need 2 points to draw a line on an XY plot. That's just kind of table stakes at this point. You need 2 points. So the reality is our data set that we actually desire in this case is to be, let's go ahead and get that data structure straightened out so that we actually work with the data set that we want. So this is really the data set that is desirable at this point, where we have values of 5.5 and 1.1. So how do we get this data structure that we desire? Once again, we're going to presume everybody starts at 0, 0 into this format up here. And so now what I'm going to do is just I'm going to go ahead and do a for structure. I'm going to index through each one of these. And for each one of these, I'm going to go ahead and build array, BA for build array. And I'm just going to go ahead and pretty much add a 0 into that. And then I'm going to go ahead and bundle it up. And now I'm going to draw that to the graph. Go ahead and disconnect that line. And once again, hey, we've got our new data set. And now things are structured the way that we want. Let this be -6. Oh, that didn't take. Delete -6. Fabulous. All right, so now we have our ability to go ahead and reshape and have our data set what we would like. But now we need a new initial starting point for changes. So now what I would say is that, well, hey, what should be our new starting point for each of these vectors? Let's go ahead and make it 4. It's a really poor man's way of doing it. 4, 3, and -8, -8. Not -8, -8. All right, and so pretty much just basically the complex math, I just need to take both of these values and just do the complex value translate, which just means I need to add really these two vectors together. So I'm just going to insert an add on that line. And let's go ahead and add those new values in. And there you go. So now I have two different vectors. The first one starts at 4, 3 and goes not to -5, 6 anymore, but basically the same magnitude and angle. And of course, we can transform our data set, just in case you didn't know. There's an entire complex data palette for doing conversions between complex to polar, real, imaginary, complex, and kind of back and forth for needs that you have. So we'll get to that momentarily. But in particular, yeah, so this is shaping up. And now the only other thing that I think we would need to do to maybe make it a little bit more cohesive in the sake of what we're looking at here is really technically we want this to be the two-dimensional array here of our actual data set so that we have our basically our beginning points and our ending points. And so I'm going to go ahead and take that, move that to there. This is our actual vector, paste it there, and now I'm going to take our starting points. All right, so now we can get rid of that secondary array. And basically what we're going to do is we're going to, for each element, we're going to pull off, we're going to index out, index array. And the first element is going to be the value that we're adding. And the second element is going to be the value of the actual vector. So there's our starting point, there's our vector, and there we go, run it again. And now we have it displaying, once again, a single two-dimensional array with starting point and vector. And once again, it's a complex number, so magnitude and direction. And so we have that. And so really, I mean, aside from me needing to have a healthy assortment of vectors along the way, we're pretty darn close to actually the desired behavior that we're looking for. We can have a bunch of vectors and a bunch of starting points for each one of those vectors, and they're plotted really on our plot. Shy of the arrowhead and the color coding, that'd be really the next step. So let me go ahead and let's just try to dive into that a little bit here. So this is going to get a little bit more complicated, a little bit more into the mechanics of modifying an individual plot color, but I think we're going to be okay with that. So let's go ahead and we're going to actually pull open a property node, create property node. Let's see what we're going to do. We're going to do reference for the graph and then generic property node. And let's go ahead. Now this is dirty LabVIEW code. Honestly, this is not my favorite, but I mean, I'm coding about as fast as I can on the fly here, trying to think of mathematical operations and also display properties. But hopefully it shows that it's definitely possible. So one of the things that we're going to do is we're going to want to change the properties of each individual plot. And the way that you end up doing it is you basically declare what your active plot is. And I'm going to go ahead and actually change this to right. And I'm going to pretty much put that to the index. So it's a 0 indexed plot. And then what I'm going to do actually is let's go ahead and take that, really the magnitude of this signal right here, right? Let's go ahead and we're going to do complex to polar. And I'm going to take the magnitude of that signal and I'm going to modify the color of the plot based off of that magnitude, really. So I should be able to go to plot, scroll down in the properties that are available, and it should be, let's see, plot, and then there is plot color. And so now I can, basically I need to transform a value of, 0 to, square root of 15 squared, or 15 squared, square root of 15 squared plus 15 squared, you get the math, basically. The top magnitude, we're going to go ahead and make it 10. Just make my life easier. So basically, let's see, how are we going to do color? Well, we can kind of, we have some color functions. Let's go ahead and see if I can make my life easier. There we go, picture functions. and then RGB to color. So let's go ahead and do that. We're going to go ahead and put, so it's automatically got the color in there, and we're going to do shades of gray. And I think this takes values of 0 to 255. Yep, so 0 to 255. So I'm going to scale a value of 0 to 10 to 0 to 255. So basically I'm going to take, let's do expression node. So magnitude, x divided by 10, and then times 2. So that'll get me normalized. And then I'm just going to wire that to all the red, green, and blue here. Let's go ahead and make some more space to try to clean it up a little bit. Once again, this is not the way I would recommend. I'm just trying to get it functional for the moment. And that should do it. Let's see what we get. All right, so there you go. There's a kind of a normalization of the individual plot colors. So now this is the trace. Now this isn't the point color. Of course, we're seeing that it's different here. So we want those two things to be the same for the moment. So because it's blue and red, so let's go ahead and get the plot. Let's see, where's the other color? Fill / point color. I get that the same. There we go. And so now, basically, based on the magnitude of the overall signal, let's go ahead and make the this one even larger. So that's to what? -5, -6, -5, -10. So that one's almost pure white at this point. It's still there. You can barely see it. Let's go ahead and just change the color a little bit so we can kind of, there you go. So that's where it is, but now it's so close, or it's over 10. That's, well, let's go ahead and we're going to scale it not all the way to 255. We'll scale it to 128. So the max value is just pure gray, right? And so, yeah, so we can see, and of course, if we change this down to -7, it should get a little bit darker, and so on and so forth. So now we have individual lines being drawn on an XY plot based on their individual magnitude. So that's not too bad. So we should be able to have a data structure. Once again, we want magnitude and phase. That makes a lot more sense, but it's complex numbers. We are plotting each one of them. And really the only thing missing right now is the arrowhead to indicate to us which direction really it's going, which of course matters quite a bit in a vector plot. So let me go ahead and pull up and pull in a tool that I made a while ago to take basically starting point and vector and turn it into an arrowhead. It adds a little bit of extra data to the plot, but luckily it's something that already exists. All right, so I'm going to go ahead and continue this. And so here's my little helper that basically takes a signal in. It actually takes in the vector in terms of magnitude and phase. It actually lets you know kind of actually what initial vector it's actually starting from. So by default, it's 0, 0. And then there's some values in terms of the actual length of the signal and the offset. The accumulate phase, if you're, basically the phase needs to be offset. So there's a couple different math-related functions happening here. But basically it spits out the new actual plot for whatever it ends up being. So we're going to go ahead and I think it actually helps us even replace some of this math that we've got here, because we can, in this case, our initial vector is, let's go ahead and create a constant, is basically going to be a value of the initial and the end point. So that's actually the start and stop of the previous vector. Now for us, really the end point is only going to be the thing that really matters, because that'll be the start point of the new vector. So we're going to go ahead and bundle our desired starting point. And once again, it goes with like anytime you use somebody else's library. In this case, I'm kind of using my own in this case. You need to understand how it was intended to be used. So there's my initial point here. There's that. So the starting point. So basically it's starting at 0, 0, and it goes to whatever point. And now I need my magnitude and phase of my desired actual signal itself, to which I can actually go magnitude and phase. So I've already got that. And I think, yeah, so it doesn't accumulate phase by default, which is good. And then the arrowheads we're going to leave by default. And so this should give us a resultant vector. We can even actually watch this run. I'm going to go ahead and pull this up on the screen and see how it runs for each iteration for the values of it. So we're going to go ahead and just kind of let this run a little bit. So we've got our first values coming through, and All right, so let's go ahead and scale that. All right, so now this is scaled very strangely, but the axes are all kind of cattywampus at the moment. That again, because it's doing the auto scale, but if we were to bring this to a much better kind of starting point or actually scaling, things should work out okay. But we are getting an arrowhead. It's just a little bit confusing in terms of what we've got. But let's go ahead and do that. Let's go ahead and get rid of that. We're going to actually use this as our actual vector for each one of these. And let's turn off highlighting. Hey, look at that. We have little arrowheads. Now we can turn off the points, point style, because we don't need those points anymore. And point style. And there we go. We have individual arrowheads based off of what we were looking for. Let's check the values that we've got. We have something starting at 4, 3, and negative 8, 8. That looks about right, 4, 3, and 8, 8. And negative 5 and negative 7 should be the actual direction. So I think there might be something wrong with basically the math that we're putting. That's okay. Yeah, so basically negative. So basically this should be, clearly we have the values that are being created here are not right. They got the right starting point, but necessarily the wrong direction. So we're going to need to look into the math with regards to that. But we know that at least the coloring is working. So let's just go ahead and get that kind of up and out of the way. We trust that that's doing what it needs to do along the way. And really the problem is not necessarily with anything other than my interpretation of how I made something a while ago. It was kind of purpose built and driven. Let's see, we've got magnitude and phase. So this is the what we're looking for. Magnitude, phase. Let's go ahead and get onto this and actually let's set those scales to be the same too. So 15 and negative 15 and 15 and 15. We could even, once again, we'll go ahead and look into, let's see, auto scale is off. And yeah, let's actually look into maybe even how this works, because we can just run it straight from here. And so in this case, my initial point is indeed 0, negative 8, 8. So we've got that working in terms of where that's supposed to be. And so now the magnitude is actually at 1.1412, which is totally fine. And then the phase is a positive phase. So that seems to be working out correctly. Now, that's actually our value of 1, 1. And so there's something kind of not quite right in the way that it's interpreting the actual arrow, because really this should just be a 1, 1 should be the value that we're looking at for that one. So really it's this VI's fault for not operating it appropriately. And let's see, negative 8, 8, magnitude phase. Let's see what my values are happening here underneath the hood. So this is just the map that we're basically using. I'm taking, because it's in degrees. That's why. So that's my fault for not actually putting that into there. So it should be phase in degrees, made that more clear instead of radians. And so now let's go ahead and actually try this again even, but now I'm actually going to go ahead and insert a, let's do radians to degrees. I'm going to insert that function in there and run that again. There we go. So now indeed we have our arrowheads associated with our plots. Of course, it's a smaller arrow, so basically it's a smaller arrowhead. It's harder to see, but of course, if we were to actually zoom in on it, we should see indeed that there indeed is an arrowhead for that. And now effectively we have it. I mean, I just need a good data set to drive through this. I think that's a, something probably wouldn't take too much to get, but maybe I could even download the advanced plotting toolkit and put that data set in here. But yeah, I mean, let's go ahead and clean up this code and see how simple it can be. We don't need this code anymore. Get rid of that. And one of the things about LabVIEW is, it's the layout of the diagram matters. But much like in a non-graphical based language, layout doesn't matter as much in a non-graphical language. I mean, Python, definitely correctly or kind of forces you to do it cleanly. But, you don't have to actually do any kind of variable naming, at least not that much variable naming in a graphical based language. And so one of the things that I like to say is, well, you don't have to go ahead and name all your variables So you don't have to create a variable for to transfer a nugget of information from point A to point B. It's just a wire itself. So go ahead and take a little bit of extra time to say clean up a diagram to make it more legible and understandable, just like variable names. You wouldn't want to name a program that has variable 1, variable 2, variable 3. You want to have them make sense. Well, same thing with the LabVIEW diagram. You want to go ahead and have your diagram legible, just as you would want your variables to be understandable by virtue of what you're doing for the games. So, making life easier for the next programmer to understand your code downstream. But yeah, I think this is about all that's needed to go ahead and do vector field plots in LabVIEW. We can leverage the XY plot, leverage the fact that it takes in complex data to simplify our data set. And really, we just, we need a little bit extra love to go ahead and make an arrowhead on an, because basically you need your original line and then 2 extra lines to be drawn. Actually, it's 1, 2, 3, so it's a couple extra lines, but it's kind of abstracted for us in, like, once again, it's something that was available and reusable out there on the web. Actually, it is something that I have posted to try to make an arrowhead on a plot if you had searched for it. And that's about it. So if you've got a data set that you want to throw at this one, I will try to post the links along with this video in the end. This has been a real fun experience to try to figure out how to make this happen. And I think, hopefully it'll benefit anybody who either wants to use the advanced plotting toolkit and maybe wants a simpler implementation, or just is curious as to how to leverage using the XY plot to display a variety of different pieces of information. So with that, I'm almost going to close it out. There's one other avenue that is the get out of jail free card for anybody who wants to do something even more advanced than this, but they don't like the graph. They don't want to deal with the graph and the axes and scales. I just want a canvas to kind of draw information, because you can do that in almost any language. When that happens, you pretty much revert back to the picture functions. Now, basically in pictures, you can draw lines, draw multiple lines. You can do text and arrows, and kind of it's an open palette for you to do things. And even more so than that, there's actually ways to actually do a mapping setup where you can actually draw axes and you can have pixels and basically do conversions back and forth. And actually these functions are the functions that the plots in LabVIEW were originally derived from, because basically it is, anytime you draw a graph, it's just a drawn picture. And this is the way to actually have even more, like, I want to draw my own custom legend, or I want to draw my own custom scale and axes and things of that nature. So you could get away from even using complex numbers and do even more and have an even more open palette and not be linked into the graph itself if you really wanted to go that far. But that's really for somebody who wants to go, and maybe that, who knows, maybe that's what the person who did the advanced plotting toolkit even did for this. For me, I'd rather keep it to the graph, take advantage of the functionality of it, and try to work around it in adding a couple extra points to add an arrowhead rather than trying to create, a pixel set. So with that, I appreciate your time. This has been, as I had mentioned, particularly enjoyable for me to make this and to try to figure out how to do this in a short period of time. I think I went a little bit over about 40 minutes on this one, so it's just under, so less than 2 times overage on the estimate. So for a programmer, that's pretty good, right? But I hope everybody has a great day, and see you in the next video.